Say what now? Shouldn't it be D minus 4 and D minus 3? Okay, but yeah, we'll give that to you, Travis. You can have it. Go ahead, dear. I'm ready. Uh-huh. Uh-huh. You're going to make the 37-week pregnant woman cry. You can have 3 points. Woo! That was good. I don't know if he had his wheeze this morning or if he just remembers his cubes, and I'm not going to ask any further questions than that. 3 cubed is 27. W to the third is W to the third. 5 cubed is 125. So he's right. It's 3W and 5. He used SOAP, so same sign, opposite sign, always positive. 3W, 5. 3W squared, hence 3 squared is 9. W squared. 5 squared is 25. 3W times 5 is negative 15. So that is literally perfect. That makes my heart happy. And now for number 10. Okay. Uh-huh. Alright, let's see. 2n squared plus 6n minus 3n minus 9. 6 and negative 3 gives you a positive 3. Yeah, that's right. You can have 2 more points. My gosh. 6 is on fire today. 2 and 4 and 3. My normal go-getter and 5. 6 is going to take you down. Oh, yeah. 1's been after it lately, let me tell you. They're going to take you down.
We got a spot in your heart. You can't tell me you go.
Well, I've yet to... Anyway, I'm recording. I'm going to watch it. I'm going to watch it. Okay, let's talk about... That makes me so happy. Okay, let's go to your notes and let's talk about some things. I had someone come in 0 period that is normally a genius, and he asked me a super blind question. So because he asked me that super blind question, I feel the need to say super blind things. Adding, subtracting, multiplying, good to go. Dividing with functions. Why do we have to have this little extra clause, like x can't be equal to 4? It is our no, 3 can have a point, and I keep calling it a no number. We would have an asymptote there. Yeah, I know, I said a bad word. It starts off with ass, I know, asymptote. Which means our graph skips over that spot. You can figure it out by setting the denominator equal to 0. You don't have to have that if 1 doesn't exist. But if 1 exists and you don't list it, you're going to get counted off. Okay, let's go to the homework you're supposed to have done today. Now, someone in first period walked up to show me their homework, and they weren't even on the right page. So let's at least make sure we're all on the same page. Literally the same page. It was that bad. Yes, that was cute. Good for you. Okay, so let's talk about this. How many points was this worth again?
20.
Drea had it out first. She can have a point.
20.
Why am I working number 5? Yeah. You would like for me to work number 5, so everyone should have number 5 done. So how people will leave the room without at least showing me they have number 5 done is freaking beyond me. But I'm typing in the zeros today, so get it together. There you go. Okay, we need to add, subtract, multiply, and divide. Let's start with adding. So if I want to add f and g, maybe I'll do f in purple. So x squared minus 1. Maybe I'll do g in green. So plus 1 over x plus 1. That's it. That's all I want. That's the answer. Now, could we have made life complicated and tried to get the same denominator and all this jazz? We could have. We're not going to. Literally, all you need to do is have f, have g, and have a plus sign in between. What is going to change when I do f minus g? Yes, it's going to have a minus sign. 4 and 5 get a point. So instead of saying x squared minus 1 plus that fraction, it's going to say x squared minus 1 minus the fraction.
Having a fraction is easy.
It looks that way, doesn't it? 1 can get a point. It sure does look that way. And then we get to multiplication, and you're like, please, God, don't give me a problem with fractions. So I can promise you this much on the test, there is not one like this. Okay, today I'm very specific about my dot with multiplication. Why am I needing to be more and more specific about that symbol? Yes, but what operation is that called?
Operation distribution. Boy.
Fog and golf. We did it yesterday. It was function. Function. It was an open circle. It's on the board. There we go. 5 years of point. Did you? I did not hear you. Would you know that? You know 0.21. Okay, thank you for being honest. Great, you can have your point. Okay. Fog and golf was function composition, so we've got to be careful about the operation in between. So if I'm doing f times g, so I've got f, and I've got to do times g, but yeah, you and I talked about this yesterday, though, didn't we? Okay, so when we multiply, that's in the numerator, so we can put it over 1. You multiply straight across, just like you used to in math class, so it's x squared minus 1 over x plus 1. So literally, he was in the top, he stays in the top. He was in the denominator, he stays in the denominator. It looks as if we're done. Don't ruin it, Travis. It looks as if we're done. Don't do it, Travis. Don't do it. Hold it in. I know you're dying to. I'm dying to too, but hold it in. Let's see if anyone else can come up with it. Okay, so if we stopped here, as DJ called it, the no-no number, what would the no-no number be? It can't be -1, so 2 and 5, you both said the number, you can get the point. However, we're not even going to have a no-no number in this problem because we can factor the top. Didn't we talk the other day about how nice it would be? We've not had any problems like this. But didn't we talk the other day about how nice it would be if only we could cancel stuff out? Now, we didn't have one in our notes. We didn't have one in our checkpoint. This is the first one where it's actually happened. But we can factor that numerator. Now, Travis, save the day. If you would like to. If someone else wants to save the day since Travis has gotten off track, that's fine. How do I factor x squared minus 1? X plus 1, x minus 1. Thank you, Abby Grace. You can have your point. Those cancel out. My final answer is just x minus 1, which means I have no denominator, which means there is no number that I'm super worried about. Now, if you want to, here you got 30 seconds to tune me out. If you're not interested in going on beyond algebra 2 or trig. If you're going past me and going on to pre-cal and cal, yes, we were able to cancel out. Yes, that's no longer going to be where we have an asymptote, but that is going to be a spot that does affect our graph. In fact, we're going to have literally a hole at that point. There will be a hole at -1. If you're able to factor and cancel it out, there's literally a hole. Like it just skips that 1 point.
So it would be like with
So you can have, so
piecewise, it would be like with the piecewise.
yes.
Where
It wouldn't exist at that one spot, yes. So it's not going to be like an asymptote where it's getting closer and closer but never touching. Instead, it's gonna pass it. It's just gonna be an open circle there. Okay. Okay, you tuned me out long enough, and me and the other people that wanted to talk about it talked about it. Let's do division. We did addition, subtraction, multiplication. Now to deal with division. Division is the one that will make you say, please, no other fraction problems, Miss Compton. Okay, so f divided by g. So f, bless you, is x squared minus 1 divided by g is 1 over x plus 1. And, oh, Lord, we have a fraction within a fraction. Okay. When you have, I know, but I told you that yesterday. Okay. When you have a fraction within a fraction, you've actually dealt with this before in an earlier math class when you were in fraction land for forever. So I'm going to explain it math-wise, then I'm going to use layman terms, and then we're just going to deal with it. Okay, so math-wise, it's like when your teacher used to have a problem that would be like 1/3 divided by 3/2. I don't know about you, but my teacher would always tell me to flip the second and multiply. When I was in earlier math class, like when I was in middle school, and there were division problems with fractions, my teacher always said to flip the second, multiply. So I would flip the second fraction. That's why it went from 3/2 to 2/3. And I would multiply in between. That's the same thing that I'm about to do here. So right now we have x squared minus 1 over 1 divided by 1 over x plus 1. So I'm going to leave this one alone. I'm going to change it to a multiplication symbol, and I'm going to flip the second multiply, so it becomes x plus 1. Now, again, if you're wanting to explain it to yourself mathematically, that's what's happening. If you're like, Jesus, take the wheel, way too deep for me, Miss Compton, that's fine. Then just remember this. You've heard 2 lefts make a right, or 2 rights make a wrong, or whatever. If you see a fraction within a fraction, the fractions go away. If you see a fraction inside another fraction, no more fractions for you. It's just x squared minus 1 times x plus 1. The fractions literally go away. So maybe I make a note to myself, fraction in a fraction, fractions go away. Yes, and so now we need a FOIL and we'll be completely done. So x to the third plus x squared minus x minus 1, and we are finally done. So the f divided by g is no big deal, except you did not know, I assume you did not know, that a fraction within a fraction really means no more fractions. Now here's the math as to why, but what's important is a fraction within a fraction, no more fractions for you. So what's really annoying is that the multiplication problem was the fraction problem. The multiplication problem turned into a division problem, whereas the division problem turned into a multiplication problem. That's just terribly annoying. Oh well, too deep. Too deep. So I've helped you with number 5. Hopefully you've got 1 through 4. Everyone seems pretty good at operations. Everyone except, I think, one person who's been absent finished and then passed their checkpoint. So everyone's good to go. Well, there might be 2, but anyway, so almost everyone's good to go on the checkpoint on operations. We started talking yesterday about compositions. Let's look back at it. We talked about Fogg and Goff. You have 1 problem still on the checkpoint today. Just 1. Do Fogg and Goff answers have to match? No, and they shouldn't today. They're only going to match starting tomorrow because we're going to throw in this word that says inverses. If they're inverses, then they would match. We haven't used that word yet, so they don't have to match. Okay, I skipped 2 problems yesterday, or 3 actually. They're on the bottom of the page before. So there's this giant box that says composition of functions, and I skipped those problems at the bottom. If you're like Jemiah and you have the checkpoint, you're like, Miss Compton, I don't know how to do 1 and 2. No, you don't, because I skipped this yesterday.
I did that.
Okay, so let's talk about how this is different than yesterday. Yesterday, we still had this notation. We still had 2 letters, and then, but it wasn't a -2. What was inside the parentheses? Every single time. X was inside every single time. 5, I heard it from you the loudest. You can have your point. Okay, so yesterday it was a little harder because we had X's. Today is actually an easier day because we have a number. Yeah, you think that. And then if one more person makes this tiny error, I'm going to die. Okay, so we're going to do things one at a time. So G is still, I wrote the same problem down twice, I know. It's still H at -2. We're still going to figure out and use this to plug in G. But instead of having to plug in with X's, we're going to have an actual number. So over here to the side, I'm going to go ahead and calculate H at -2. I need to know H at -2. Yes, Siri, you can have your point. Okay, so you looked at h. It used to be x squared plus 6x plus 8. But now everywhere I used to see an x, I put in a -2. And here is where everyone's making their error today. Yes, that's -12. Yes, that's plus 8. On God's green earth, what is -2 squared? Positive or negative? Then how come everybody on this choke point today is going to come up here and have squared number and got a negative? I don't know why. Okay, and then when I add this all together, what do I get as my final number? It is 0. So I calculated h at -2. It's 0. So let's go back to our problem. I know what h at -2 is. It's 0. So I just want g at 0. You and I figured out h at -2 was just the number 0. So really, I just want g at 0. So now I've got to go look at g. G used to be -2x plus 1. But instead of x, I'm going to plug in a 0. And what do I get as my final answer? My fridge making a noise, yeah. Will whispering, yes. I don't know. What other things am I supposed to hear?
You get that too?
That's my fridge.
Oh.
Okay. So again, we found this number. It was 0. We then took that and plugged it into G. I've seen this a ton on the ACT. Sometimes they'll even go 3 deep, so like F, G, and H. Okay, I can't variable today. I can barely people today. So erase the A. I just can't. It's not you, it's me. So we want to do F at G at 3. So over here to the side, I'm going to go ahead and figure out G at 3. G was -2x plus 1. G was -2x plus 1. But everywhere in I see an x, I'm going to put a 3. So now G of 3 is actually what number? Say what now? Did you just say -5? Okay. Did you type it in your calculator? -6 plus 1 is -5. Okay. So we want to know F of -5. Well, F is 5 times X. We don't want to use X. Everywhere we saw an X, we're going to replace it with -5. So our final answer is -25. So we figured out F at G of 3. It's -25. Again, it's not that deep. You just got to keep up with what you're doing. Find the number for G of 3. Evaluate G at 3. Find that number. And then evaluate F at that number. Okay, are there any questions about this? I like this. I like this more than composition. This is evaluating with composition. I like this more than just composition. It's fun.